Hi, good evening, everyone. The class will begin shortly. Okay, if you can see this, my screen, could you just type so in the chat, please? Okay, good night, Liam. All right, Amelie. All right, I'm just waiting for a few of you all to come into the. Hi, good night, Janelle. Hi, Kilon. Okay, hello, Kian, Carissa. Good night. Okay, well, let's begin. We have enough of students that we can start. All right, tonight for our inspirational thought, I want to share with you something that Steve Jobs said. The only way to do great work is to love what you do. If you haven't found it yet, keep looking, don't settle. All right, so if you really want to be exceptional at what you do, find something you love, okay? Find something you love and you will do it and it wouldn't feel like work. Now, obviously, I know you have to get through school and there are things that you have to do like math that some of you may not like, but you have to do it at this stage. But for a job like for your future career, find something that you love, okay? All right. Last night we had a software problem that caused the audio and the visual to freeze, and eventually I lost audio. So I'm gonna finish the question that we were doing, and then we'll continue here with day 8, relations, functions, and graphs. So we are in section 2, so we have a lot of work to get covered tonight. So we were doing here May 2017, and we were doing 8F. And I'll just briefly go through the working here, because I would have wrote out all of this last night. It's just that you would not have heard the explanation. So last night I taught you all a technique called iteration. So we make an initial guess. We had to show that there is no diagram that has exactly 1,000 dots. So we made an initial guess here that n is 50. All right, this is the figure number. And when I substitute the figure number n is equal to 50 into the equation, I'm getting this number of dots. Now we want it to check for a value of n that will be either close enough to 1,000, all right, to verify whether or not this is so. So 1275 is too much, so I made a suggestion to try 5 less, which is 45. When we worked out 45, all right, this is where the feed cut. So you would have gotten here 1035. So I would have recommended, and I saw someone named Brent Frederick, he would have suggested to Naomi to try 44 and 45, and he was right. So when you try 44, you will notice here that you'll get 990. So recall here that the figure number is a natural number. So what this means is that when n is equal to 45, there are 1035 dots, and when n is equal to 44, there are 990 dots. Therefore, there is no value of n that has exactly 1000 dots. Okay, and that was the explanation. I'm sorry you guys didn't hear the last part of what I had to say before I ended the class. Okay, so let's begin. Okay, so January 2019, paper 2, question 8. Part A1. Complete the table below for the function f of x is equal to 3 plus 2x minus x squared for 1 mark. So I want you to go ahead and complete this table, please. Good night, Chad Seeley. Good of you to finally turn up again. Hi, Ms. Nanlal. So for those of you who don't know what you're doing, you're taking each value of x here. So when x is minus 2, you're going to substitute in the function here f of x. And when x is 2, substitute the value of x is equal to 2 into this function as well. All right, and let's see what values of f of x we're coming up with. So I'm going to start the working while you work. Let's see what you have. So f of x is equal to 3 plus 2x minus x squared. So f of minus 2 is 3 plus 2 by minus 2 minus 2 squared. So f of minus 2 is equal to 3, 2 multiplied by minus 2 is minus 4, and minus 2 squared is positive 4, but this minus sign here makes it negative. So f of minus 2, this is 3 minus 4 minus 4 is minus 8. So f of minus 2 here is minus 5. So I will put this here in the table. Okay? F of 2 is 3. That's correct. All right, but work out this one, f of minus 2. So f of x here is equal to 3 plus 2x minus x squared. F of 2 is equal to 3 plus 2 multiplied by 2 minus 2 squared. So f of 2 is equal to 3 plus 2 multiplied by 2 is 4. And this is minus 4. F of 2 is equal to, this is 4 minus 4 is 0, so this remains a 3. Okay? How many of y'all got that? I'm not seeing many of you getting that at all, you know. So you're going to put here, this is 3. Okay. Excellent. That's sounding better now. Well, reading better there. That many of you are getting it. So let's go to part 2. A part 2. Complete the grid below to show all the points in the table on page 25, and hence draw the graph of the function f of x is equal to 3 plus 2x minus x squared for minus 2 is less than or equal to x less than or equal to 4 for 2 marks. So this is the table here. And you have a graph there. So go ahead and plot the graph, please. Go ahead and plot the graph. Your graph would look something like that, okay? Okay. Now connect the points. Tell me when you finish, okay? F of x is on the y-axis, yes. Finish. Well done, Tinia. Well done, Amelie. Kaylon. Okay, so everybody got something looking similar to this? All right. So part 3 here. Using the graph on page 26, determine part A, the coordinates of the maximum point of f of x over 1 mark. So you have to use the graph here. Now the maximum point, what's the coordinate of it? It's this point here, this turning point here. Brittany, we starting every night with January 2019, and then we work backwards. So 2-4 is not correct, Kaylon. Check over your working. 1-4 is correct. All right, notice that it's 1 across on the x-axis and you're moving up here 4 units, okay? So just write here 1-4. All right, part B. The range of values of x for which f of x is greater than 0 for 2 marks. So you have to go back to the graph. So they want the range of values of x. So what is the set of values of x, or the domain, that has a positive value of f of x? You could see here that f of x, or this portion of the graph here that is greater than 0, it starts here when x is greater than minus 1. Notice that x is equal to minus 1, it is 0. F of x is 0. So it starts to be greater than 0 at when it does not include minus 1. And in the same way here, at x is equal to 3, f of x is equal to 0. So we're looking here for values of x here that will be minus 1 is less than x less than 3. Is that clear, everybody? I'm going to say it again. All these the values of x between here and here have a value of f of x greater than 0. The y value is greater than 0. That's why the curve is up here, okay? But at x is equal to minus 1 and at x is equal to 3, f of x is equal to 0. So we have to write an inequality here for the domain that has f of x greater than 0. So that's what I did here, where minus 1 is less than x. It's not less than or equal to x. So it's less than x, and x is less than 3, not less than or equal to 3. Everybody clear with that now? Okay, so I'm going to move on here. Part C, the gradient of f of x at x is equal to 1. All right, so we have to go back to the graph here. And in order to find the gradient here, just now, at x is equal to 1. At x is equal to 1, at x is equal to 1, you go up here, and you would see that this is a turning point. Now, you'll draw a tangent to this point here, all right, and you find the gradient of this line. But really and truly, you don't need to, because the gradient of a horizontal line is 0. Always, okay? So, you could just write that the gradient is 0 because the gradient of a horizontal line is 0. You don't need to do y2 minus y1 all on x2 minus x1. This is standard, okay? But you could prove that mathematically for yourself some other time. It's always 0. Okay? Everybody clear with the explanation? Okay. Part B here now. Mr. Thomas makes X bottles of juice and Y cakes each day. To supply his customers, he makes at least 20 bottles of juice and no more than 15 cakes each day. Part 1. Write two inequalities to represent this information. Alright, so I want you to go ahead and write two inequalities for this. All right. I'm not seeing any inequalities, but I'm going to start working here now because this is pretty straightforward. So X here is for bottles of juice and Y is for cakes. So he makes at least 20 bottles of juice. So which means he makes a minimum of 20 bottles of juice or more. So therefore X here is greater than or equal to 20. All right. So that's the first inequality. And he makes no more than 15 cakes each day. So the maximum number of cakes he makes is 15 cakes. So it could be 15 or less than 15 cakes. So therefore, Y here, which represent cakes, is less than or equal to 15. Okay? That's your answer there. No, Kaylan. No, 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 no. No. Just what I have there. X is greater than or equal to 20 and Y is less than or equal to 15. Okay? All right, part 2 I will have to explain because this CXC paper had an error. So I want you to understand the reasoning why I identified it as an error, and I will show you the right thing to do, okay? Part 2. Each day Mr. Thomas uses $163 to make the bottles of juice and the cakes. The cost to make a bottle of juice is $3.50, while the cost to make a cake is $5.25. Write an inequality to represent this information for 2 marks. All right. The problem is CXC's wording of the question here. They said each day Mr. Thomas uses $163. So he's not using more than $163 nor less than $163 to make whatever he's doing. So you're not going to write here an inequality because it's not more or less. It's just equal to 163. So I'll just cross out inequality here and write equation. So I'm going to write an equation here. Remember X represents juice and Y represents cakes. So we could write here 3.5x plus 5.25 y is equal to 163. All right, and that's the answer there. Everybody clear with that? Please type in the chat, let me know. I got 1 yes, boy. All right, 2, 3. Nope. Well, Jade, you in Form 4. If you didn't totally understand this, I'll excuse you a little bit. Okay. All right, even though this would have been covered in functions, Jade. All right. Part 3. Show that on any given day, it is not possible for Mr. Thomas to make 50 bottles of juice and 12 cakes for 1 mark. So here X is equal to 50 because 50 juice is X and cakes is Y. So Y is equal to 12. All right. So I'll take the equation here that I derived from part 2. So here we have 3.50x plus 5.25 y is equal to 163. And I will substitute the values of x and y into the equation. So this is 3.50 multiplied by 50 plus 5.25 multiplied by 12. And this is equal to 163. So I'm going to expand out these terms here. So 3.5 multiplied by 50 here, this is 175 plus 5.25 multiplied by 12 here. This is 63. And this is, you'll notice we put it here equal to 163. But when I add here 175 plus 63, you would see here that I'm getting 238. But 238 is not equal to 163. 238 is greater than 163. So what happened is that this level of production exceeds Mr. Thomas's daily expenditure of $163. Watch here. Remember, each day Mr. Thomas uses $163. So if the $238 is more than the 163, so what we write here, this level of production exceeds Mr. Thomas's daily expenditure of $163. So it is not possible. Okay? Yes, Yusuf, all that for 1 mark. CXE generally, what they will do, right? Most of the marks here, they will give it for easier type questions. And this is what differentiates students who got distinctions from grade 1s. All right, when they could answer questions like these. Now, for those of you doing economics, if there's anybody here or who probably will watch this again, this, you would have studied production possibility frontier. What happened is that this equation here is the production, represents Mr. Thomas's production possibility frontier. And this production level of X, 50 bottles of juice and 12 cakes, is outside of his production possibility frontier. So with his current technology and so on, these this level of production is unattainable. Okay, so it's infeasible for him to produce 50 bottles of juice and 12 cakes every day. But that's the economics meaning of it. This is really an economics question that they give, but they just let you do the maths, okay? All right, so we have finished with 1 question for tonight. Well done. We have 3 more to go. May 2018. Part A. The diagram on page 25 shows 6 points of the function y is equal to 3x plus 1 over x. The coordinates of these 6 points are given in the table below. Part 1. Complete the table by calculating and inserting the missing values of y for 2 marks. So what you're going to do here, you will substitute here x is 0.5 into this function here, and x is equal to 2, and find the y values. Listen, if you find section 2 hard for you, don't skip it. Go through it at least and make sure that there are little things that you could do like this. It's just 2 marks you could scrape it up, okay? It's just to substitute the 2x values in here and find the y values. Okay? So when x is 0.5, y is 3.5. When x is 2, y is 6.5. That's correct, Brittany. For the others, I want you to work it out, please. Okay, so let me start the working here. So they gave us here that y is equal to 3x plus 1 over x. All right. When x is equal to 0.5, we have here y is equal to 3 by 0.5 plus 1 all over 0.5. Y here is equal to 3.5. So right here, 3.5. And when x here is equal to 2, we have here y is equal to 3 multiplied by 2 plus 1 all over 2. So y here is equal to 3 multiplied by 2 is 6. This is 6.5 or 6.5. Everybody clear with that? All right. So we're going to move on here now. In part 2 here, on the diagram on page 25, the ordered pairs shown in the table have been plotted except for the missing ones, the ones that we just calculated. Using your answers in A part 1, plot the missing points and connect all the points with a smooth curve for 2 marks. Okay? So you're using these 2 points here. When x is 0.5, y is 3.5. When x is 2, y is 6.5. And you're going to connect the other points that I plot here in the graph. So I need to plot my graph too. Y'all doing any kind of graph work here is challenging, eh? So bear with me. So when x is 0.5, we have here y is 3.5. 3.5 is here. No. Sorry. This plot in the wrong place. All right. And when x is 2, we're looking for 6.5. So this is 2 here. $6.5. All right. So I will attempt to connect these points. Bear with me, please. All right. It's not a perfect graph, but it's the best I could do right now in a short space of time, okay? Okay. You all got that? Y'all are real quiet in the chat tonight. All right. So let's go back here now for part 3. By drawing an appropriate straight line on the graph on page 25, find the appropriate solutions to y is equal to 3x plus 1 over 5x. I think I made a little typo here with this question. I think it's supposed to be equal to 6. All right. Just let me verify a question here. Could you just tell me if this thing is supposed to be equal to 6? Yes. 3x plus 1 over x is equal to 6. This is equal to 6. Okay? Liam, you would have seen a blank screen because I had moved off the screen I wanted to show you just to make sure that I'm giving you the right thing, okay? Someone like I didn't type that. Okay. Now I know that this is not a perfect graph. So what I did, I'm just gonna show you what you were gonna do. You're gonna do something called graphical interpolation. Now to interpolate is basically estimating between two known values, okay? So you're gonna come down to the y-axis here, and you're drawing here a horizontal line across to intercept the 2 points on this curve. Okay? I'm just gonna change the color here. Let's probably try green here. Alright, and what I'm gonna do here, now remember that my curve isn't that good, but I would have used interpolation. I could tell you about interpolation because I've taught you that while we were doing the questions yesterday, and we referred to it today. And I will tell you what the answers you should get. Okay, because obviously my own wouldn't come out that good. You see, interpolation will actually give you a more accurate answer than just doing this thing graphically. Yeah? Remember, everybody will draw a curve slightly different. So that's one of the reasons why knowing interpolation is good. But they ask you to do this graphically. I just did the interpolation on one side. So you'd read off your two values of x that are the solution when y is equal to 6. Now, what you will get here, you're looking for x is equal to anything around 1.8 and x is equal to 0.18, which should be around 0.2, close to there about. All right. So 1.8 is the better answer. So let me just write this in. So the two values of x says 1.8 and x is equal to 0.18. These are the two answers you will get. Obviously, I would have done the interpolation and get it to to 2 decimal places, but you can't read 2 decimal places on that graph. Okay? Well, 3 decimal places, I should say, not 2. Okay? So these are the values of x. So by drawing the appropriate lines, find the approximate solution. So I'll go back again, explain what you did. Then you know that the function here is equal to 6. So I need to solve this and find the two x values that this will correspond to 6. So I draw a straight line across here. Then every place that this straight line intercepts with the graph, I draw a vertical line down to the x-axis to identify the x values that will give a y value of 6. Okay? And that's what I did. Now, as I said, using interpolation, I would have been able to verify what would actually be the correct answers. So, they are x is equal to 1.8 and x is equal to 0.18. Everybody clear with that? All right, part B. The speed time graph below shows information on the first 60 seconds of a car's journey. Okay? Part 1. Calculate the acceleration in meters per second squared of the car during stage 1 for 1 mark. Now, I want to work this question and I'll tell you why. I don't like how it's phrased out, simply because from a physics point of view. And let me explain to you why. This is a speed time graph, and they're asking me here to calculate. Yes, Sheriff Rose, I know what is this physics. Yes, it is physics, and let me explain to you what it is. This is a speed time graph. Speed is a scalar quantity, it's not a vector quantity. So, you could find the acceleration. Speed has an instantaneous acceleration because the direction would change. So even though you're seeing a uniform speed here, what if the car is moving in a different direction? Okay? So what we have to do is to make an assumption that the car is moving in a uniform direction. Yes, I know physics is French and foreign to many of you, but it's not to me. And that's why when I read this, it's gonna sound a little strange. When I read this question, I just found it wasn't specific enough. Okay? So I have to make an assumption here that stage B, the car is moving in a straight line. Okay? Alright? So now, if the car is moving in a straight line, what happens is that this becomes velocity. No longer this stage B here of the graph would become velocity. So, it's very easy to find the acceleration. Now, the acceleration of a velocity time graph for this stage here is given by the gradient of stage B. Okay? So, the acceleration here would be the final velocity minus the initial velocity all over, well, this will be T2 minus T1. So let's go to the graph here. This is the initial velocity here, which is 15. Oh God. Yes, which is 15 meters per second. This here is the final velocity, which would be 40 meters per second. The final time, T2, is 60 seconds. The initial time here is 40 seconds. So, I am going to substitute. So, let me just write this here so you can see it back, right? V here is 40 meters per second. The initial velocity here is 15 meters per second. All right. T2 is 60 seconds. T1 is 40 seconds. So substituting here. That is just gradient to the Mustafa. That is just gradient. Y2 minus Y1 all on X2 minus X1. I just wrote it out more like how it looks like in physics. Okay. So you don't even need to write V minus U, T2 minus T1, Y2 minus Y1 all on X2 minus X1 will be fine. Okay? So, this here is 40 minus 15 all on 60 minus 40. So, A here is equal to 1.25 meters per second squared. Okay? Meters per second squared. All right, that's the units of acceleration. So let me just run it through again. They said calculate the acceleration in meters per second squared of the car during stage B. Now I told you, because Brittany, I saw your answer earlier on. You are correct. Well done. So in stage B, in a speed time graph, there was an issue here because speed has instantaneous acceleration, and the acceleration of speed will change based on the direction, even though if the car is accelerating here. Okay? So what I had to do was assume that stage B car is moving in a straight line. So I wrote an assumption here. Assumption, the car is moving in a straight line. So now I could find the gradient of that stage B here, and this will actually be velocity because it's moving in a straight line now. So the acceleration is the final velocity minus the initial velocity all over the change in time. Okay. Oh, y'all, sorry. It's where the microphone is positioned. I'm sorry. Didn't realize I was speaking so loudly. Is it better now? All right, so making the substitution here for the velocity and the initial velocity, final velocity, T2 and T1. I'm going to work this out here. 40 minus 15. This is 25 all over 20, and I'm getting here an acceleration of 1.25 meters per second squared. You would notice that this was for 1 Mach. Okay? All right, this was a 1 Mach. As I told you all, these are the things that help people get distinctions. Part 2. Calculate the average speed of the car during stage B for 3 Machs. Now, in order to find here the average speed, what you need to do is to find the distance traveled by the car. And the distance traveled by the car here is the area under the curve. So what I'm going to do here, I just want to draw in a trapezium so you could see. So you're going to find here the area under the curve by finding the area of a trapezium. This will give you the distance traveled. And you know here, the time taken, 60 minus 40 will give you the 20 seconds. Okay? So find the area of the trapezium. We could call this A. You could call this B. A here, this will be 20. B here will be 40. And H here, 60 minus 40 is 20. Okay? Area of the trapezium. So half A plus B multiplied by H. Okay? Yes, you have to learn it, Tania, but there's actually give you this one in front of in the formula sheet as well. Okay? This one, this formula has always been the formula sheet. Listen, look at the examinations that CXC would have had recently. Look at the formula sheet and familiarize yourself with what formulae are coming and what aren't coming. So at least you know. All right, you can still bank on something in case you forget. But my recommendation, learn everything. So how many of y'all got 550 meters? All right, now that's the distance. We have to take the distance now and divide it by time, the 20 seconds, and you'll get the speed. Uh-uh, 700 is not correct. Check over your working. So the distance traveled is equal to half A plus B by H. So this is a half multiplied here by 15 plus 40 multiplied by 20. And I'm getting here 550 meters. Okay, learn from the diagram. Oh, I made a mistake here. A is 15. Y'all, I'm sorry here. This is 15, not 20. I read bad. My working is correct, but what I wrote here is wrong. Yes, that is correct. Gaming with red. 27.5 meters per second. Alright, let me take my calculator and do this. 0.5 multiplied by 15 plus 40 multiplied by 20. 550. The working is correct. Alright, so let me run it back through again. We need to find here the average speed of stage B. In order to find the average speed of stage B, we need to find the area under this curve. Under this graph here. Now, when I draw vertical lines here, you would see that this is a trapezium. And the area of a trapezium is given by this formula. Area is equal to half A plus B multiplied by H. A here is 15. Okay? When you go across here, this is 15. And B here, this is 40. When you go across here, you see that this is 40. You're clear with that so far? And 60 minus 40 is 20. So the height here is 20. All right. So I'm using these values here, substitute them in, and I'm going to get here 550 meters. So that's what I did here. That's what I did here, okay? You clear that? Yes. So now, we're not finished. Remember they asked us to find average speed. So we could write here that speed, well, average speed is equal to distance traveled over time taken. Okay? The distance traveled is 550 meters. Time taken here is 20 seconds. So I'm getting here 27.5 meters per second. Okay? All right, so that's part 2. Let's go on to part 3 now. At t is equal to 60 seconds, the car starts to slow down with a uniform deceleration of 2.5 meters per second squared. determine how long will it take the car to come to rest. So 1 mark. Y'all, you see this 1 mark story? Again, the working is a bit. Let me explain to you the physics behind it. But it's a 1 mark. Just remember that, okay? 1 mark to frustrate you. From stage B here, the car is decelerating at 2.5 meters per second squared. Okay? And they want to find out how long it will take from a speed here of 40 meters per second. It will decelerate here. Okay? So I'm going to do the working, but again, I'm going to assume that the car travels in a straight line as it decelerates. All right? So I'm going to make that same assumption. Y'all, and this is to preserve the physics, okay? Okay. Now, acceleration here is defined as the rate of change of velocity. All right, and you could write that from that definition. You could actually write here that acceleration, the rate of change of velocity here, is the final velocity minus the initial velocity all over time. Okay? So you have this formula. Some of you would recognize that this is the first equation of motion, which they derive from the assumption, from the definition of acceleration. V is equal to U plus AT. All right, that's the first equation of motion. It came from the definition of acceleration here. So, the initial velocity here would be 40 meters per second, and the final velocity is when it's at rest. Okay, 0 meters per second. Y'all, I know some of y'all catching rail kicks, alright? Because you're dead lost. But bear with me, alright? So, the initial velocity, the final velocity is 0 meters per second. The initial velocity here is 40 meters per second. Alright? And the acceleration. Now watch this here. Because it's a deceleration, it is negative 2.5 meters per second squared. Okay? Now, if you're not doing physics or add maths and you're not really strong with the maths, you would not have realized that, okay? But anytime you have deceleration, it's always negative meters per second squared. Alright? And they want us to find time. So I will substitute here the final velocity, the initial velocity, and the acceleration and solve for time. So this is minus 2 is equal to, the final here is 0 minus 40. Okay, I'm not sure what happened here and this disappeared. All over the time here is what we want to find. I don't know why they put all this physics here, but what are you going to do? Minus 2 is equal to 0 minus 40 is minus 40. Put this over t, put this over 1, cross multiply. Minus 2t is equal to minus, y'all, I keep making a mistake here. This is minus 2.5. When this thing disappear, it threw me off. Minus 2.5, minus 2.5, minus 2.5. Okay, and this is minus 40. Divide here by minus 2.5. Divide here by minus 2.5. This cancels. So t here is minus 40, all on minus 2.5. T here is equal to 16 seconds. That's okay. Look, the math exam always have some kind of physics, and sometimes it has some kind of crazy economics as well. Okay? Yes, I know it's a 1 mark. Hence the reason why. No, Kaylan, the acceleration is minus 2.5 and not minus 2. When I was writing it just now, somehow it disappeared from this screen. Alright, I don't know why it disappeared, and then it threw me off. But I made the correction yet. This should have been minus 2.5 as well. Alright, from here, minus 2.5. Okay, listen, I know this is hard for many of y'all. Brittany, I believe you got it correct earlier on. Alright, you gave me the 16 seconds some time ago. Yes, you did. Alright, so well done. I'm gonna move on, alright? I don't know why I'm sounding loud tonight. The mic is in the correct position where it should be. Maybe it's best if you lower your volume, okay? Alright, so let's move on. This is the end of May 2018. Let's go to January 2018. Okay? Alright, so this is January 2018. Y'all, this is a typo. This is 2018, not 2019. Alright, January 2018, paper 2, question 9, part 1. Show by calculation that the exact roots of the quadratic equation x squared plus 2x minus 5 is equal to 0 are minus 1 plus or minus the square root of 6, so 3 marks. Which one is Joanne Timothy there? Kaylon? Okay. Welcome, Joanne. I've been looking for you for days now. All right. So, you have two ways you could do this. You could complete the square or you could use quadratic formula, but quadratic formula is longer. The root is longer, so I would recommend completing the square root. So go ahead and do this, please. This I believe you all will be able to handle. It's not physics. Yes, one more to go after this. Yeah. Game with red, I understand that the quadratics are ugly for you, okay? Now, I'm not too sure if we're finishing early tonight, you know. Alright, we might just finish on time. The quadratic formula, yes. The completing the square you should have as well. Liam, don't worry about that, okay? Yes, I finished the class when I finished the papers, Kadim. Okay? I have a certain amount of work I plan to do every night, and I go on. So let's see here. So I'm going to use the completed of the square root. So we have this quadratic equation here. So I could write here the coefficient of x squared is already 1. So I don't need to factor it out. Okay? So this is x squared plus 2x, and half of the coefficient of x here is 1. So this is plus 1 squared minus 5 minus 1 squared. This is equal to 0. Now, we have a perfect square here. So we will say that this is x plus 1 all squared minus 5 minus 1 is equal to 0. X plus 1 squared minus 5 minus 1 is minus 6 is equal to 0. So we're going to take this minus 6 across the equal sign. So this is x plus 1 squared is equal to 6. Now I want to remove the square, so I have to take the square root on both sides of the equation. When I take the square root of a square, I remove the square. So this becomes here x plus 1 is equal to plus or minus the square root of 6. When I take the square root of anything, the answer becomes plus or minus. Okay? So therefore, x is equal to minus 1 plus or minus the square root of 6. Please note you could have done this with the quadratic formula, but it is longer. Okay, that's the answer. They ask us to show by calculation the exact roots of the quadratic equation are these. Okay, and I've done that. Show it, meaning that they would have given you the answers and you just have to show how you're coming up with this. Emmanuel, the year is written right here, January 2018, paper 2, question 9. Okay? Let's go on to part 2. Hence, otherwise, solve the simultaneous equation. Alright? So go ahead and solve the simultaneous equations. This is a linear and non-linear. Jade, please refrain from doing that, okay? Emily, you have to go back to Form 4 and revise that. Now, remember, when you start working here for the simultaneous equation, where you probably call this equation 1 here and this equation 2, and you make a substitution, you'll work down here and you'll realize that the roots here from 9a part 1, you could use them. Okay? Okay, I'm going to start the working here. So I'll write here 2 plus, excuse me. So I'll write here y is equal to 2 plus x, and I'll call this equation 1, and I'll write here that xy is equal to 5, and I'll call this equation 2. And I will substitute here equation 1 into equation 2. So what this means is wherever I see y, I'll place 2 plus x. So this becomes here x, open brackets, 2 plus x is equal to 5. And I'm going to expand the brackets here. So this is 2x plus x squared is equal to 5. 2x, that's not one. Let me just put the x squared before. So x squared here plus 2x minus 5 is equal to 0. And what I wanted you to see here from part 1, you would see that x squared plus 2x minus 5 is equal to 0 has these roots here. Okay? Notice here, x squared plus 2x minus 5. It's the same quadratic equation from part 1. So you don't need to solve out for the roots already. You already have the x values. So what you need to do here is to solve out and find for the y values. Okay? So from 9a part 1, okay, the roots are this will be minus 1 plus or minus the square root of 6. Okay? Now, when you work out this on your calculator here, you have two values of x here. X here is 1.45 and x here is minus 3.45. And what I want to do is substitute each of these x. When you work out this, you would get these values of x, one of this and one of this. Okay? And you would substitute each x value into, I'll use equation 1. We have here y is equal to 2 plus x. Y here is equal to 2 plus 1.45. Y here is equal to, this is 3.45. And the same here, here I'll use equation 1. Y is equal to 2 plus x. Y here is equal to 2 plus minus 3.45. Y here is equal to minus 1.45. Okay? So those are your two values of x. All right. Let me go it over again. You'll look really, really troubled with this thing, okay? Here we have a simultaneous equation, linear, nonlinear, okay? So what this is that we want to solve them simultaneously. Y here, I'll substitute for equation 1 into equation 2 because there's a y here. All right, when I make the substitution here, this becomes y. So this is 2x plus 1. Expanding the brackets here, I'm getting 2x plus x squared is equal to 5. I'm going to take the 5 across. It's going to become negative. And this is equal to 0. Now from part 1 here, they gave us that these are the roots. Okay? These are the roots. So I just wrote here from part 9a, 1, the roots are these. Now, this here, this value 1.45 is actually minus 1 plus the square root of 6 would give this value of x, and minus 1 minus the square root of 6 would give this value of x. Okay? And we take in these two values of x and substitute them into equation 1 here. And you work down, you get your two y values. So, if you want, you could draw a table. You have x, you have y. You have two values of x. This is 1.45, and when x is 1.45, this is 3.45. And when x here is minus 3.45, y here is equal to minus 1.45. Okay? All right, I've seen a few I got it to understand. All right, I'm going to move on here. Not frustrate you all who don't understand this, okay? Yes, it was to solve for y now, the values of y. Okay, 9b. The incomplete table below shows values of x and y for the function y is equal to 2 to the power of x for integer values of x from minus 1 to 4. Part 1. Complete the table for the function y is equal to 2 to the power of x. Alright, so they gave you here, this is your domain, this is your function here, y is equal to 2 to the power of x. You have 1, 2, 3, 4 missing values. Substitute the relevant values of x into the function and come up with these. This is really easy. This is easy to marks. Listen, if you cannot do everything in section 2, pick off the easy parts, okay? Jovan, don't let your grandfather hear you writing that. Yeah? We dead inside. We are all dead inside here. You know, he expects a lot more from you. All right? Y'all don't worry. Yeah? Jovan is a really bright boy. All right? He just plain mad here. Okay. So work out the values of x, the values of y here. You could do this out on your calculator if you want. This is 0.5. This is 2. This is 4. And this is 16. All right, 2 to the power of minus 1 is 0.5. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 4 is 16. Everybody clear with that? Okay, so that was part 1. On part 2 here now, okay. In part 2 here, on the grid provided, draw the graph of y is equal to 2 to the power of x using a scale of 2 centimeters to represent 1 unit on the x-axis and 1 centimeter to represent 1 unit on the y-axis, so 4 marks. Okay? So, they give you a graph here. So, all you have to do is to plot out these points. Plot them out. So, I'm going to do that now as quickly as I could. 2 centimeters to represent 1 unit on the x-axis, 1 to 1 on the y-axis. So this here, -1, 0. Ah, okay, so I'm gonna plot this out. So -1.5, 0 is 1 here. 1 here is 2. 2 is 4. 3 is 8. And 4 here is 16. Okay. Oh, oh boy. Thank you for pointing out that 11 is twice now. Oh boy. Y'all, usually that's why I like to plot these things before. Eh? I'm terrible with it online here. Okay. So now to connect the points. Let's see if I can pull this one off properly. Wow, that's good so far. Well done, brother. All right, so I'll take this and go, okay? That's what the graph's supposed to look like. Gaming with red. You didn't understand fully the question at first. Oh, but you understand it now. Thank you, Naomi. Y'all, drawing with a pen tool is not that easy online. It takes a lot of practice. All right. But eventually you get it with time. All right. So that's what it looks like here. Now, part 3 here. Draw appropriate lines on your graph. Drawing appropriate lines on your graph determine the value of x for which 2 to the power of x is 11 for 2 marks. So, 2 to the power of x is 11. So what I'm going to do, I go up here to 11. And this is graphical interpolation. I'll just make this a different color just now. What color you all want here? I'm gonna put purple. Pink, turquoise. All right. So far, pink winning. Light blue. I go hold off for the pink, seeing that I use red. All right. Liam, what kind of voter pattern thing this is, huh? You voting twice? Okay. Now, what you're supposed to get here, to be honest with you, is around 3 point, about 3.35, 3.4 thereabout, okay? That's what you're supposed to get. I'm getting here 3.5 on the graph here that I sketched off, but on the working that I have, it this is supposed to come up around 3.4. Okay? So I'm just gonna give you the 3.4 answers, but I'm just trying to demonstrate, what it is, because it's easy for me to just show you the working, and some of you need to see how it's done as well. So x is equal to 3.4. All right, now 3.3 is still fine, okay? You allowed some level of subjectivity with this because it's a graph you're doing. All right, so we are finished here with this question. So we just have one more to do for tonight. And we just are at the half an hour mark, 8:30, so we're on time. Okay, so this here is May 2017, question 9. The velocity time graph shown below shows the motion of a cyclist over a period of 40 seconds. Part A, calculate the gradient of OA for 1 mark and then AB for 1 mark here. So this is OA, all right, and AB. Now remember, AB is a horizontal line, and we just learned earlier, some time ago in the class, that the gradient of a horizontal line is so much. All right, the gradient of a horizontal line is 0. So you could just write the gradient of AB as 0 and tell them the gradient of a straight line is 0. Okay? So that's an easy 1 mark you pick up there. And for OA, use y2 minus y1 all on x2 minus x1. All right? So go ahead and do that, please. The gradient of OA is 0.4. That's correct. So I'll write here for the gradient here for OA. O has 0.00. A has coordinates, not points, but coordinates of O is 0, 0, and A here has coordinates of 25, 10. So the gradient of OA is y2 minus y1 all on x2 minus x1. All right? And this is 10 minus 0 all over 25 minus 0. So I'm getting here 2 over 5 or 0.4. Okay? Now, because this is the gradient of a velocity time graph, the units will be meters per second squared. Okay? No, Isaac Newton. Oh, Isaiah Newton. My bad. It's not minus 0.4. Eh? All right. For AB here. Yes, I'm seeing too much physics tonight. AB is a horizontal line, and we know that gradient of a horizontal line is 0. So, okay? All right, good. Part 2. Complete the following statements. The cyclist started from rest where his velocity was so much and steadily increased his velocity by so much each second during the first 25 seconds. During the next 15 seconds, his velocity remained constant. That is, his acceleration is that amount. So I'm going to give you back the graph here. Do that statement, please. Do you all have your past papers? Because you need to be able to see the graph to do this as well as the statement. I understand, Liam. I understand. Sometimes that happens. Just not paying attention, it happens, okay? No, if I split it, Deshaun, if I split my screen, what will happen is that it wouldn't display properly, okay? That's one of the reasons why I type the questions and not put pictures to display to you all. When you all start to tell me it's blurry, this is the clearest I could get it to display for you. Okay? I'm sorry. That's why I encourage you all to print out your past papers. There's a lot of preparation that goes into making this possible. Alright, so let's see how we could do this quickly. The cyclist started from rest where his velocity was. Alright, so let's go. He started at rest. Rest means 0. Alright, so he started at 0 meters per second. Alright, and steadily increases velocity by, now notice here, he's increasing his velocity so much meters per second every second. So this is the acceleration. The acceleration that we calculated here is 0.42 over 5 meters per second squared. Yes, I have a link to the past papers. Just go on my YouTube page, the homepage, and look at the trailer video. In the description there is there's a link to a shareable folder on Google Drive that has the past papers. Okay, Isaiah? You could easily download them from there. Alright, so this here, I'll just put 0.4 meters per second. All right. During the first 25 seconds, during the next 15 seconds, his velocity remained constant. So therefore, his velocity isn't changing. So therefore, his acceleration is not changing. His velocity remains constant, so he's not accelerating. So his acceleration is 0 meters per second squared. Okay. Thank you, Liam, for sharing the file, okay? All right. Y'all clear with this, right? Part 3. Determine the average speed of the cyclist over the 40-second period. So, in order to find the average speed, we did a problem like this earlier. We need to find here the area under the graph. And, excuse me here. Okay, so what you need to do here, you're going to use area of a trapezium. So let me just make this a little more clear to you. Okay, so you have your height here. Your height here is 10 meters per second. All right, and you could call any one A and B. 40 minus 25 here. This is 15. So we could call this A is 15. B here is 40. Okay? So find the area under this graph here and you will get your distance. All right, and I told you memorize this. Area is equal to a half A plus B multiplied by H. So I'm going to do the work in here now. $275 meters is correct. Now take the time from for those of you who got the 275, take the 40-second time for the journey and find speed. Yes, find average speed. So this here is a half A plus B multiplied by H because area of a trapezium. So this is a half. What did I use as A here? I used 15. B as 14, H is 10. So I'm getting here 275 meters, and your average speed is equal to your distance divided by your time. This is 275 divided by 40. So I'm getting here 6.875 meters per second. All right. Generally, we tend to put things to two decimal places. So if you leave it like this is fine, but 6.88 is fine as well, okay? You all understand the steps to this part of the problem? Yes. Well done, Brittany. Okay? Well done. Well done to everybody. So remember, when we have to find speed, we have to find the area under the graph. That will be the distance traveled. Take the distance divided by the time taken. Yes, I know it's physics, but it's maths too. Okay. Part B. Consider the following pair of simultaneous equations. X squared plus 2xy is equal to 5. X plus y is equal to 3. Now, y'all, please, don't run ahead here. Yeah, it is correct, Brittany. You are correct. It is correct. Let me just flash back on my screen. It's the same working. Okay, you are very correct. So, part 1 here. Without solving, show that 1, 2 is the solution for the pair of simultaneous equations. So, here, what this means, remember when we're writing coordinates, it's always x, y. So, x is 1 and y is 2. Okay? So go ahead and do this, please. You're not working it out. Let me see if you have an idea what to do. I'll give you a minute and then I'll start working. All right. Random Kadim. So if we are using bigger time, do we have to convert it smaller? No, just use whatever units and time that they're working with. But generally, when we're doing calculations, we work in SI units. So you preferably want to convert things to seconds. All right. But if they're working in hours, then just work with the hours. Yes, you get a real physics answer there. Well, I am proud of you, Brittany. You're doing very well, okay? Same to you, all of you. All right, so let me show you here. They said without solving, they show that x is equal to 1, y is equal to 2 is the solution of the pair of simultaneous equation. So what you're really doing here is substituting here x is 1 into the equation and seeing if the left hand side is equal to the right hand side. All right, that's all. So when x is equal to 1 here, we have x squared plus 2xy is equal to x is equal to 1 and y is equal to 2. All right, this is the first equation here. X squared plus 2xy is equal to 5. Substitute x is equal to 1, y is equal to 2 into the equation here. So this is 1 squared plus 2 multiplied by 1 multiplied by 2 is equal to 5. 1 squared is 1 plus 2 multiplied by 1 here is 2. 2 multiplied by 2 is 4. 4 is equal to 5. 1 plus 4 is equal to 5. 1 plus 4 is 5 is equal to 5. So therefore, the left hand side is equal to the right hand side. And this is true. Okay? Everybody clear with this? Yes, that is correct. So now we did this for this one equation. Let's do it for the second equation. When x is equal to 1, y is equal to 2. The second equation here, x plus y is equal to 3. So 1 plus 2 is equal to 3. 3 is equal to 3. So the left-hand side is equal to the right-hand side. All right, and this is true. So therefore, x is equal to 1, y is equal to 2 is a solution to the pair of simultaneous equations. Okay? All right, so that's the working for that. Y'all clear with this? Seeing some yeses, so I'll move on here. Part 2. Solve the pair of simultaneous equations above to determine the other solution. Remember, when you have these linear and nonlinear equations, you usually have two values of x, two values of y. We already have one set of solution here where x is 1, y is 2. So they want you here to solve for the other two values. So go ahead and do that solving, please, and then I'll work it out. Y'all, this is the last part of the question for the night, huh? And we're done. Giving with red, maths is not an alien language. It's a universal language that everybody speaks across the world. Okay? It's just that we have to just learn the way of communicating with it, okay? Okay, I'm gonna go and start the working, alright? I don't want to take too long. You should be at least ahead of me. So we have here y, oh god, x squared plus 2xy is equal to 5. I'll call this equation 1. And we have here x plus y is equal to 3. And I'll call this equation 2. Now, from equation 2, which is the linear equation, and that's the general route we take for this type of problem. We take the linear equation and make one of the terms the subject of the formula. So I'm going to make y the subject of the formula. So y is equal to 3 minus x. So I'll call this equation 3. And I'll sub here equation 3 into equation 1. So I'll write equation 1 here, x squared plus 2x. And wherever I see here y, I'll replace y with 3 minus x. And this is equal to 5. Okay, so let's expand here. X squared plus 2x multiplied by 3 is 6x minus 2x squared is equal to 5. So let's group up the like terms. Bring everything to the left hand side as well. So this here is x squared minus 2x squared plus 6x minus 5 is equal to 0. So this becomes here minus x squared plus 6x minus 5 is equal to 0. So we have a quadratic to solve here now. So 1 multiplied by 5 is 5. Factors of 5 whose product is 5 and whose sum is 6 here. So I will use here minus 1 and minus 5. No, I'll use here 1 and 5. So this is going to be here minus x squared plus x plus 5x minus 5 is equal to 0. The HCF of these first two terms here is minus x squared divided by, the HCF is x, not minus x. Minus x squared divided by x here is minus x. Positive x divided by x here is positive 1. I'll repeat the brackets. This is minus x plus 1. This is equal to 0. 5x divided by minus x here is minus 5. Minus 5 multiplied by positive 1 is minus 5. So this works out. Factorize out the brackets here. Minus so this is minus x plus 1. And this is x minus 5. This is equal to 0. So let's take each of the brackets equated to 0 and solve for the roots. So minus x plus 1 is equal to 0. So therefore 1 is equal to x is equal to 1. That's the first one. The second bracket here, x minus 5 is equal to 0, x is equal to 5. Now we already have the solution here for x is equal to 1. You notice that from here. They gave us when x is 1, y is 2. So we just need to find here the solution when x is equal to 5. So I'll sub here x is equal to 5 into, I'll use equation 3. So here we have y is equal to 3 minus x, y is equal to 3 minus 5, y is equal to minus 2. Okay? So therefore, all right, the other solution is x is 5. Let me write this clearly. I don't want you to think that this is a minus 5. X is 5 and y here is minus 2. Okay? Okay, so that's the answer there. All right? X is 5, y is minus 2. That's the other solution. All right, class, we've reached the end of the class. We have solved the 4 questions. I know that this was challenging just for you all to just stay up and try to focus and make some sense out of this. Go home and do some revision, please. Look at the syllabus on the relations, functions, and graphs. Look at the different things that you need to learn. Learn off your formulae, please. Learn off your formulae. Tomorrow we are doing circle geometry and trigonometry. Question 9. I love that topic, too bad. So I hope I could translate that love to you all, alright? So I would see you all tomorrow. Alright, God willing. Alright, take care and have a good evening. Alright, good night. And until tomorrow. Bye-bye.